let's start. I'm waiting to learn names. Let's start. Okay, my friends, we're going to run one iClicker today. It's sort of bizarre. I heard that iClicker is not running. One iClicker, hopefully. If it didn't work, then I don't know. We'll do something else. But I do only one of them. So today we're starting section 14.2, and we may not be able to do iClicker. There were a few pre-lecture videos for 14.2 to remind you of limits in one dimension. 14.2 is limits in two dimension. Limits in three dimension follows loosely from what we have in limit in two dimensions. Fair game? Now, let me remind you, when we were doing limits in one dimension, what was the shape of the limit? You would write limit as x approaches a of f of x equal to L, right? What did it loosely mean? It meant as x getting closer. That's not getting closer to a, f of x gets closer to L, right? Okay, so which direction did you have in CAC 1? These are CAC 1. What direction did you have? This is the number line for x. We would have left and right. Right? So this is x equal to a. We would get closer to a from left or right. Now I'm going to tell you about my dilemma for two dimensions. You ready? You're ready? Okay. So the dilemma of two dimensions, here's my space, x and y. So what is the point in the input? Let's say domain is in here, right? Domain is a subset of R2. So a point in the domain is what? I have to do A and B, right? A and B. Now, I'm going to introduce limit of f is a function of two dimensions. How many variables inside? X and y, right? So I have to be able to say that input is approaching a point, right? So underneath it, this is important to keep the notation. Notation, notation, notation. Right? Location, 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 notation, notation, notation. I have a function of two variables. The input is approaching A and B. Then I will have L. Right? Now, what does this mean? As input x and y approaches A and B, or getting closer to A and B, the output f of x and y is getting closer, closer to f of, sorry, ignore me, to L. It's limit. Sorry about the two things that I had to scratch out. Again, when the magnitude of x and y minus a and b, the distance between the two of them, approaches 0, it implies that f of x and y minus L is approaching 0. this getting closer mean? Let's go back to Calc 1. You said either right or left. There were two directions. And at the end of Calc 1, you learned something more. You learned that limit of x approaching a from right should be equal to limit of f of x approaching from left, right? And that gives you, therefore, limits exist. If only Calc 3 was this simple. It turns out there are ways that are even simpler, but it's not that simple. Look at this point. How many directions? Can I approach from right, left, above, below, sideways, sideways? Oh, how about that one? Or this one? Oh, I don't like the straight line. How about this one? All of those. So how many different ways can you approach? Infinitely many ways, and they're different paths. They don't have to be straight line. So the problems that we're setting up in Calc 3, this was this page. This part was this page. That picture is that picture in your lecture notes. Sorry I didn't bring those up. So it turns out that basically, having all infinitely many steps, I can compute limits through infinitely many paths to prove the limit exists. What I can do, I can say that there are at least two paths that give you different limits, so the limit doesn't exist. For existence of limits, I cannot use paths. Can you guys repeat that for me? For existence of limits, I cannot use paths. For showing limit doesn't exist, I can use paths. Fair game? Okay, so let me write this down so you guys have it on your notes. Because there are infinitely many directions to show that limit exists, we cannot use limits of the paths. Limits on the paths. So I can say from left, from right, from above, from this side, from this path, right? But I can give you, I can use two paths with different limits to show that this doesn't exist. That's an arrow, D and E. But there has to be different limits. Fair game? Okay. Let me tell you, when we're talking about paths, we're talking about, I did not drop the mic. That's okay. We're good. I dab myself a little bit sometimes. There we go. So, no, I was driving to school today, and then the guy behind me started giving me high beams. Like, what is going on? He stops me and says, your back tire is completely flat. Like, it's like, so I park And so I have to take care of it later. But it sort of deflated me. I don't know why. I drove with it too. So, fun story. We're people too. And so that's the, when I talk about paths, let's see, when in this limit, when we are talking about paths, they are parameterized. Let's say x of t and y of t. And there's a funny thing about them. Limit of, there exists t, c, such that as t approaches c, this limit is going to be a and b. So the path, the limit of the path is going to be a and b. Look at this picture. Limit of the path, where'd the picture go? Right there. Oh, that one also, the one up there. So every of these are ending up at a and b, basically. And so then we can replace them back in here. So limit of this path is going to look like this. You plug those in, and you get limit as t goes to c of f of x of t, and I have an extra parentheses, and y of t. So you replace that limit by that over a path. When we talk about limit over a path, we're replacing the path inside the limit, making it a limit of one variable, right? One direction makes it one variable. But because there are infinitely many of them, I cannot prove that limit exists through this, but I can show that limit doesn't. So far, you're okay? Okay, let me give you a few nice things. So it turns out, if your function, do you guys all know what elementary functions are? Yeah, so give me an example, like what kind of function? Doesn't have to be a particular example. Squared, square root, exponential, what else? Trig functions, logarithmic, all of those, except for those that are piecewise defined, right? So what we know about the elementary functions, they are continuous on their limits. What did we do when we had elementary functions in Calc 1 to find the limit? You plugged it in, right? You did direct substitution. So for elementary functions, they are continuous. So let me tell you about the continuity first. Continuity is very much defined the way we defined it in Calc 1. If a limit of f of x and y as x and y approaches a and b exists and is equal to f of a and b, f is continuous at a and b. So the limits exist from all directions and is equal to the value. The second is that if f is continuous at any x and y in its domain, then f is continuous on its domain. Last, if f is elementary, it is continuous on its domain. So these are the definitions you need. The continuity on the domain, continuity at the point, continuity on the domain, and elementary functions. Now I'm saying that for all the elementary functions, so according to those, to find limit for elementary functions, plug in the input. That's direct substitution. Substitution. What is wrong with my substitution? Substitution. There we go. Do the direct substitution. Example time? All good so far? Let's do, oh, I gave you the answer. That was unintentional. So that was so far, so good. Very much CAC 1. You're still not in need for stretch or anything. Here. Are these elementary functions? Yeah. That's like sort of a polynomial in one dimension. This one is a polynomial type in 2 dimensions, right? So they are elementary. Now, is -2 and 1 in the domain of this function? How do I know it's in the domain? Plug them in. So let's plug it in. If I plug in that point in here, what am I plugging in for x? So for x, I'm plugging in 2, -2 to the power 2, for x, -2 plus 1. And I get what? Did I do it correctly? No, positive. But -7. So -8/7. So because this was part of the domain, it was continuous, I just direct substituted. I can do the same thing here. This is all elementary functions, added, subtracted, everything. What do? I plug in the input value, which is 2 and 4. Let's see. 4 for y, for x, 2 over 4, then entire thing to power 2. So I get 4 arc sine of 1/2 to power 2. Arc sine of 1/2 is what? Pi over 6. And then you simplify, you 2/3 of pi to power 2, 4/9 of pi squared. That's the, so elementary functions are easy. What'd you do? Just plug in, right? You plug in. Let's do one iClicker. It might not work. Our iClicker system is not working today. I don't know why. Sometimes it happens. It may be something. I may have to close it after this and never open it again. You got it? Can you guys put in your iClicker? No? You got it? So I can plug in u as square root of x squared plus y squared, right? Does that work? So the inner function is elementary. The inner function is square root of x squared plus y squared. Right? And it's a nice elementary. It doesn't do anything weird. What's the limit of inner function? What's the limit of square root of x squared plus y squared as x and y approaches 0, 0? 0. So the limit of inner function is 0. Right? And so if I plug the inner function in the outer function, inner goes to 0. Is it true or false? Okay. Did everybody get that? Nope. Who said nope? No? So the inner function goes to 0, right? And so if I do g of a u where u goes to 0, the whole function goes to L. So in here, I have g of u is square root of x squared plus y squared. That goes to 0. So as x and y goes to 0, 0, it goes to 0. So it's OK. Fair game? Did that make sense? It may be. OK, so I may have to throw this one away. Let's enter the truth, please. If it works, I'll give you points. If not, I'm going to erase it. Well, the inside also goes from right direction. Square root of x squared plus y squared is positive. OK, 4, 3, 2, 1, 0. Let's see if it worked. No, it's not working. I'm sorry, guys. I tried. I did stop. It didn't work. Do you see this? Sorry. Don't leave me, though. Listen to the rest of the lecture. I'm ending the class. Yeah. Stay because of the fun stuff that is going to happen. So first thing first, I want to give you an example of how to find the limits on paths. Did you guys remember I said limit in paths I have to parameterize? So let's do that. Here, what is A and B here? 0 and 0. Can you give me some lines through 0 and 0? Y equal to x. What else? This one, y equal to 0. Y equal to x squared is one of them also. Can I use it next time? Y equal to x squared. And then, I don't know, this one is x equal to 0. If I'm parameterizing line, y equal to x, instead of t, I can pick x. My x parameter can be x, right? So the parameter is a parameterized form. Looks like x and x. Or t and t, however you want to. So what does x approach for this to approach 0, 0? X has to go to 0 to go 0, 0. So that's a side work. Side note. For us to understand. If I'm computing the limit on y equal to x, it will look like this. See, x goes to 0. Then for For x, I plug in x. For y, I also plug in x. If this confuses you, use t instead. T is more confusing because it looks like plus. So that's why I'm using x. X at least looks like a cross. Right? You guys are with me? So now, this is a parameterized curve. So for x, I'm plugging in x. For y, I'm plugging in x. X squared plus x squared. Everybody okay so far? Chose a parameterized curve, and I plugged in, because y was x, I plugged in y equal to x. And x was x also. Now, let's simplify this. Top is x squared, the bottom is 2x squared. What is this limit? Huh? 1/2. So through this one, and actually I didn't specify x bigger than 0, so that one also. Right, both of them gave me 1/2. Now, what was the other path? Y equal to 0. Let's parameterize. Line y equal to 0, it goes through 0 and 0. Right? What's the parameterization of this? X and 0, right? X is changing on y-axis, on x-axis, but y is always 0, right? The parameter can be x and 0. Everybody agrees on that? Y-axis is x and 0. And now, what is seen here? X should approach. I want this to approach 0, 0, so x should approach 0. So the limit on y equal to 0 is limit as x goes to 0. For x, plug in x. For y, plug in 0. So what do I get? I get 0 limit 0 over x squared as x goes to 0. What is this limit? That one is 0. Wait, 2 different paths. Actually, each one of them is 2 on its own, but that's okay. Just 2 different lines going through 0, 0. I got 0 on one path, 1/2 on the other path. Does the limit exist for this problem? No, it doesn't. So the limit doesn't exist. It does not agree on 2 paths. Can you guys see this? Okay. I want to show you something cool. You ready to see something cool? Are you into cool stuff? Partially because I can't. There we go. Do you see that the function is a function that I have right here? Right? That's the surface of this function. This function is graphed right here. That's the graph of this function. Now, do you see the origin? The value of the function at origin? Look what's happening. As the function gets closer to origin, what do you think that value, z value, is? What is that z value? Where does the function hit the z-axis, you think? Almost. It doesn't, but almost. What is this value? 1/2. 1/2. Where am I approaching at y equal to x? Now, if I look at it this way, do you see the bottom? It also at y equal to negative x is approaching negative 1/2. Then on the x-axis, I can see that it approaches origin. It approaches 0. So you can see through the creases on the surface of the graph that different paths lead you to different points over 0, 0. So over 0, 0, you have different paths. It has like a crease on top and crease on the bottom, and then on the sides, it goes to 0, 0, top goes to 1/2, bottom goes to negative 1/2. That's the fun part. And so you can see it, and with some examples on that, you can see it better. I'm going to move on to a method because I cannot run the iClicker. If I go over all the methods for when it doesn't exist, it's not useful because you guys don't get to do any. That's a problem. Let me do one more that doesn't exist, then do one more that exists. And so do you guys need to talk to each other for a minute? 15 seconds talking to each other, see if you can figure anything out that you missed. And raise your hand if you didn't understand it. Questions for me? None? Aiden, questions? What is bothering you, Duo? What is bothering you? Yeah, I see that the gears are turning. You got it? Okay. You're tired. So the gears are turning, but you're tired. I'm afraid to ask. I'm afraid to ask. Should I? No. I figured. Yes. No, you cannot show it exists. I'll tell you in one quick minute. Let me do one more. Can I start? I'm going to start. So now, let's go back here. What is the point that I'm approaching in a domain? 0, 0. There's something funky happening here. The funky part is that through every line that approaches 0, 0, I'm going to get same limits. Let's try that. What are the lines that goes through 0, 0? Give me a bunch of them. What's the line that has y-intercept is always 0? Y is equal to x. Generalize that. Y equal to mx, right? Y equal to mx is any line that approaches this way, right? Except for the x equal to 0. So y equal to mx, parameterize that. So x and mx. That's a parameterize. So I parameterized it. Now I'm going to go plug it in. So limit. So to x and m, for x and mx to approach 0 and 0, what does x supposed to do? X goes to 0. So for both of them to go to 0. Now I have x squared. Instead of y, I put in mx. X to the 4th plus mx to power 2. Let's simplify as much as possible. Mx to power 3, x to the 4th plus m squared x squared So the limit as x goes to 0 is mx to the 3, x squared factors, x squared plus m squared. Agreed on this? Everybody agrees on this? Now what do I need to do to find the limit? Right? So limit is mx over x squared plus m squared. Right? And let's say for m not equal to 0. For m not equal to 0, what do we get? The bottom, is it 0 or is it not 0? The top, 0 or not? 0. So the entire thing is 0. So for infinitely many lines, I got the limit was 0. Infinitely many paths. But there is a non-straight path that is going to give me non-zero. So who said y equal to x squared last time? Say it again, Alex. So we're going to choose y equal to x squared this time, this path. All of these, all straight lines, limits was the same. It did not help me. Now I'm going to choose this path, y equal to x squared. Parameterize it. What is the parameterization? X and x squared. So the limit as x approaches 0, for y plug in x squared. X squared, x squared, x to the 4th plus x squared to power 2. X squared to power 2 is x to the power 4. So I get limit of x to the power 4 over 2x to the power 4 as x goes to 0. Simplify that. Limit as x goes to 0 as 1/2 is 1/2. Wait a minute. All of these straight lines, the paths, gave me the same limit. This one gave me 1/2. Does limit exist or not? It doesn't exist. Limit d and e. So the cool part of this, that you can see that on the graph of this one also. If you look at the graph of this one, can you see the parabolas? One parabola takes you to 1/2, the other parabola takes you to negative 1/2. Rest of them take you to 0. Funky business? Is everybody ready to see a limit that exists? Whoever wants to see a limit that exists out of the limits that are not elementary. Wait a minute, did everybody understand this was not elementary? Did I emphasize on that? Why was this not elementary? When I plug in 0 and 0, what do I get? I get 0 over 0 form. So it's not elementary. That's why I tried something else, right? How about this one? If I plug in 0, 0, what do I get? I didn't write the form down. 0 over 0, so not elementary. That's the difference. It's not part of the domain. It has to be piecewise. Okay, are you guys, whoever is ready to see a limit that exists, raise your hand. Me too. Not many people, actually. Why? Okay, so let's do a limit that exists. And then next time when we come back, I'll do all the eye clickers. It gives you a little time to think about the eye clickers also. Think about the stuff. So one way, when we're computing a limit in 2-dimension, let's see, this is a point in 2-dimension. Point in 2-dimension. closer and closer. What do I mean by closer and closer to this point? What word do you use? Distance is getting smaller and smaller, right? So what is the distance formula? Let's say x minus a to power 2, y minus b to power 2, right? What about if this is origin? It's x squared plus y squared, the square root of that, right? That's the distance. So we're saying as distance getting smaller and smaller. So when the distance is 2, then distance less than equal to 2, distance is less than equal to 1/2, distance is less than equal to 1/4. What is that shape that you're forming? You're making small disks. This getting smaller, smaller, smaller into getting closer and closer to point, right? So why not use polar coordinates? Because we're really saying we're getting smaller and smaller. Polar coordinate tells me that when r gets smaller and smaller, around the origin, right? We can translate any point to origin when it's not elementary, the function is not elementary, and make it smaller and smaller, grab around it with polar coordinates. So use polar coordinates. Let me see. Do you guys remember what polar coordinates were? That is plug in x equal to r cosine theta, y equal to r sine theta. Okay? Then, typically after that, you have to do some process. Let me do that by example, right? Why are we doing this? Because it's like I have a point 0 and 0, and the disk is getting smaller and smaller. That's why. But let's give some examples. Let's find this. So I'm plugging in, when I plug in x equal to r cosine theta, y equal to r sine theta, tell me what x squared plus y squared is going to be. When x is r cosine theta, y is r sine theta, what is x squared plus y squared? Everybody agrees on that? Always simplify this. Noah, is this okay? Looks great. Okay. I can't tell if you can see it. That's it. Okay, so r squared. So back in here, I'm going to plug in e to the power r squared minus 1 over r squared. Agreed? Now when I'm finding the limit, when I say that x and y is getting closer and closer to 0, what does that mean? It means that radius is getting smaller and smaller. So I can write it as limit as r goes to 0. Sometimes people put that in. It's kind of iffy. You really don't need that, but I don't want to argue, so I leave it there. R is always positive because we're doing two-dimensional. But then what is happening to theta? It doesn't matter because I'm just looking at the domain that is getting smaller and smaller around the point. Now, well, I forgot to very first check. Was the form 0 over 0? When I plugged in 0 in here, I got 1 minus 1 and 0. So the form was 0 over the 0. This hasn't changed the form yet. You have to do things to it to change the form. It's still 0 over 0. But does this look familiar to you? We've seen this. What can I do when I have exponential? It starts with L and ends with all? The hospital. I thought it was very clever. I don't know. So derivative of r squared is the easy one. What's the derivative of the other one? What am I missing? Derivative of exponent. Are you guys doing okay? Yes, yes, what do I do? Yes. No. Thank you. Who said that? Thank you, Aiden. You saved me. Saved me from my own. Okay. Now, can I simplify? Can I plug in? Is it 0 over 0 anymore after simplification? Oh, 2 is going to go also. Not 0 over 0. Plug in, what do I get? So I found the limit. So this is one of the best ways of finding limits, but not, I notice this didn't look like the stuff that I did so far, right? So you guys want to see something that I did so far that looks like that and has a limit. 10 seconds of talking to each other. Do this stretch, do this stretch, 10 seconds. Okay. Can I do it? Do the neck stretch, arm stretch. Do the engineering and math and science geek stretches. Oh, you do not yet? Because of typing, you always have to do this. Okay, I'm starting back. Let's try to do it on this one. Is this 0 over 0? Yes. Let's plug in. What do I get? R squared cosine squared theta, agreed? R sine theta. What's the denominator? R squared. R goes to 0. Theta, I don't know. Remember, on this problem, theta disappeared. I didn't have any problem with theta. But theta may not disappear every time. And this is a case that theta will not disappear. But R doesn't disappear neither. So when I have this, what do I have left? This and this go away. I will have limit of R, cosine squared theta, sine theta. R goes to 0, theta goes to, I don't know. Okay. R goes to 0. That's the only hope I have. Because I have a function that goes to 0. This goes to 0, right? And can this get infinitely big? Why can it get infinitely big? So what's the maximum I can get out of this? What's the minimum? Now multiply it by R. What can you get? Right? Agreed? As R goes to 0, what does this go to? What about this? Wait a minute. Limit of that is 0, limit of that is 0. What's the limit of in between? But what theorem? Thank you, guys. By squeeze theorem. I finished on time. Limit of R cosine squared sine theta. Okay, I'm going to continue a little bit on Friday, though, and then start 14.3. Ian, a little bit on Friday, 14.2, then 14.3. Let me write it down. Hello. I know your name. I know your name. June.
I have a question. So when you're comparing your limit,